Over 5 billion mobile phone chargers are used every single day to charge our mobile phones around the globe. This is the same number of videos watched on YouTube every single day. Each one of these chargers weighs around 100 grams. Large power transformers that are used to transmit power from power plants are weighing around 370,000 kilograms. And there is a wide spectrum of different power converters in between, all of which are meant to do one job: power conversion. But why do we need power chargers, transformers, or power converters? Power plants that produce energy through rotating machines generate alternating current, and that is known as AC power. While other sources that involve static elements generate direct current, and that is termed as DC power. AC current modifies its polarity periodically from positive to negative, while DC current keeps in one polarity even if it is fluctuating. Solar cells, batteries, and fuel cells, and some types of generators can produce DC current. This DC current comes with a voltage potential from a few volts to multi-hundreds or even thousands of volts. So the voltage levels can be different from one source to another. According to these voltage levels and the nature of current mode and the applications meant to be supplied, PCs, TVs, or lights, the mode of convergence of power somehow geniusly can be divided into 4 different categories. The AC to DC converters, and that is commonly known as rectifiers, DC to AC converters, and these known as inverters, DC to DC converters, which include choppers, and finally, the AC to AC converters. You may be wondering, why should we convert the power from DC to DC or from AC to AC? Okay. As we mentioned before, DC waveforms can be at different voltage levels, and if we opt to convert from one level to another, we need a DC to DC converter. The DC to DC converter can be either step down or step up converter. Also, there are several types of converters that can wear 2 hats, one for stepping up and the other for stepping down the voltage. AC to AC converters are useful in converting the voltage from one voltage to another or changing the frequency of the AC waveform. In some applications, the system requires multiple conversion of the voltage waveform, so sometimes we are required to convert the power from AC to DC, then from DC to AC, using one converter but at different stages. Look at these examples. If we require to charge a battery of the mobile phone from an AC source, what type of converter do we need? AC to DC converter and control for charging the current are needed. We also need to watch the voltage amplitude. If the AC source is 240 volt and the DC battery needs 5 volt, so we have to step down the voltage. Another example, if the battery is the power source and we need to control the speed of an induction motor, what type of converter do we need? Yes, DC to AC converter. Look at this. If the power source is a 50 Hz AC and we need to control the speed of an induction motor, an AC controller is needed. A DC to DC converter is needed for DC motor speed control to generate a regulated DC supply from a storage battery or to control the speed motor in a subway. Motor drives are also part of power converters family because the motors require variable voltage or variable frequency power supplies with the aid of power electronics. A big number of applications use power converters. PV farms need DC to DC converters to regulate the voltage to the required amplitude. Then an inverter can be used to supply a single-phase grid. Wind turbines can use AC to DC conversion stage, then another DC to AC converter that has the ability to supply a three-phase system, for example. Most of these converters transfer the power in one direction only. Future trends in power conversion tends to focus on the converters that have the ability to convert the power in two directions, from the source to the load and vice versa. And those are called bidirectional power converters. So then, why should we stop converting power in one direction? Because bidirectional converters have the ability to provide more interaction with the power grid and then provide service to the customer without consuming more energy from the generators. I hope that you enjoyed this video and thanks very much for watching.